Alright everybody, welcome back to Mr. Buckingham's Physics Problem Solutions. In this problem we're going to be tackling number 4 from our kinematics set. It is once again broken up into an A and B section. Let's go ahead and get started. A truck traveling at 108 kilometers an hour is slowed down at a uniform rate of 2.5 meters per second squared. So already we have some information that we're going to underline. A truck is traveling at 108 kilometers an hour, so that's a speed, and in particular then it's slowed down at a rate of 2.5 meters per second squared. So let's go ahead and write this in. We have an initial velocity, v naught, of 108 kilometers per hour. Then we have an acceleration which is equal to negative 2.5 meters per second squared. Now, how do I know that it's a negative acceleration and not a positive? Because it's being slowed down. That means that this is getting less and less. It's getting more and more towards the negative numbers, which means we have a negative acceleration. Alright, A. How much time does it take before its speed is reduced to 1/2 the original value? Alright, so in order to even start this one, what we need to do is figure out by saying, okay, what is the target velocity that we're looking for? What is the velocity that we want? In order to do that, I'm going to go ahead and say, alright, so our v naught, and we're looking for half of that, right? So we divide v naught by 2, that's 108 kilometers per hour divided by 2 gets us our 54 kilometers an hour. Right? That's given to us in the problem, but I wanted to make sure that everybody knows how I got that number in the first place. Okay, so this is our target velocity that we're looking for. And what we want to find out is how long does it take to get here? Okay? Since we know, right, that this is being halved, we'd say that our delta V, okay, should be 54. In other words, our final velocity minus, and really it should be a negative 54. Our final velocity, okay, is 54, so that's our final, minus the initial of 108, okay, we should have a negative 54 change in our velocity. That is the 54 kilometers an hour less than it was originally going. Alright, so now we can go back to our basic equation. We have acceleration is equal to velocity over time. Okay, and in particular, what we're looking for is to solve for time here. Alright, if we use our triangle, we're going to see that time, okay, is equal to velocity over acceleration. Alright, again, that is to say a v t. Here's our little triangle. We want to solve for t, so we get v over a. Alright, and now I'm going to actually plug in our velocity. Okay, the change in velocity here is 54 kilometers per hour. Our acceleration is negative 2.5 meters per second squared. Okay, and what we're going to find out is that the time it takes to slow down this much is 21.6 seconds. Alright. Now, what we're going to do is we're going to take a look at the second part, right? This is the time for A to get to half speed. Now, time for B. How far will it travel before its speed is reduced to 1/2 the original value? So now we're going to find out how far did it go during this time. Alright, we can use our formula of delta x, okay, the change in distance is equal to v naught plus v over 2, okay, that's our average speed times time. let's go ahead and plug some numbers in. V naught, we're starting at 108 kilometers an hour, plus V. This is our final velocity, the 54 kilometers an hour, over, okay, 2. Alright, the whole thing over 2. Sorry guys. So we want the whole thing. I'm going to write this out a little bit more clear. There we go. Alright, the sum of that over 2 times the amount of time it took. 21.6 seconds. Alright, now if we go ahead and work this out, alright, we have 108 plus 54 gets us 162 over 2 times our 21.6 seconds means that it covered a distance, covered a distance of 1,749.6 meters. And that's the answer that we're actually looking for. Alright, so we have this number, the 1,749.6 meters. We want to go ahead and make sure that this makes sense to us, right? If we take a look back at the beginning, we said that it was going 108 kilometers an hour. That's moving pretty fast. We're talking about over 1 kilometer a second, or a minute, I'm sorry, 1 kilometer a minute. And then we're going to say, okay, well, it's slowing down at 2.5 meters per second, which isn't very fast. That's a pretty slow deceleration. It takes 21 seconds. It should make sense that this is a reasonable number, our 1,749 meters. Now, if this number was something like 17 million meters, then that really wouldn't make sense to us, okay? But we do want to check back and make sure, does this make some sort of logical sense to us? Does it seem reasonable? And this is well within a reasonable limit. Alright, hope you enjoyed that. As always, if you have any further questions, make sure to stop in and see Mr. Buckingham and enjoy the rest of your time.